Okay, so let's do some problems to practice. Let me see if I can find some problems. All right, so I'm gonna do some problems for you, but not all of them. All right, I'm also trying to like maybe change some numbers so that I'm not doing your homework assignment. You know what I mean? Um, all right, so these you can definitely use calculator. Just do it the way that I show you. Use a calculator on this, or if you want to do it by hand, that's fine too. But these are pretty straightforward. Um, and then this one right here, you can definitely write a sigma notation and then do it with a calculator. Let me see. Oh, and if the ratio is negative, and then also with a fraction that is less than 1, uh, is most likely going to be convergent. Make sure you remember that, all right? Make sure you remember that. Uh, all right, these you can use calculator. All right, these are just writing the notation. Where the word problems at? Write an explicit formula in terms of n for each recursive defined. Okay, so you have to change it from recursive to explicit. Um, all right, I'll do one for you, and you do the other one. Um, let's see. All right, so whenever I'm doing sequence, whatever problems that I'm doing, I always try to make myself a table. If you make yourself a table, it's just a lot easier to understand. So right here, if I want to make a table for this problem right here, right, first value is 10, and then this is the recursive formula. So let me put it this way. So you're going to have position number and then the values. And then when position is 1, all right, when position 1, your value is at 10. And then according to the recursive root, the current value, whatever values that you're trying to do, the current value is going to be equals. It's going to equals the previous value plus 5. So if I want to find position 2, it's going to be the previous value and then plus 5. So that means the next one will be a 15. And then the next one, you need the previous value plus 5. So that means you'll do 15 and then plus 5. So that means you're going to get 20. And then when you want to get to the fourth one, position is 4. You're gonna have to do a plus 5 again, and then you're gonna get a 25. All right. So once you make yourself a table, you can go ahead and write the explicit formula. So the explicit formula is going to be the generic one is a n right here, and then it was the first value plus difference, and then position minus 1. So now all you have to do is plug in numbers. All right. So first value is 10. So plug in the 10, put it right here, and then plus the difference, which is right here. And then you're going to need n minus 1. You're going to need n minus 1. So this is the explicit formula. So you change from recursive, now you are at explicit. So whenever you're doing any of these problems, make yourself a table, all right? Make yourself a table. All right, let me see what else. What are the word problems? All right, here we go. These are the word problems. All right, so let's do one of them. Let's do number 11. Find the sum of the first 60 terms of the sequence below. Explain how you determine your answer. Alright, so 15, 17, 2, and negative 15. Alright, so once again, make yourself a table. Make yourself a table. So you have your position up here, and then the values down here. So position is 1, 2, 3, 4, 5, 6, 7, and so on. And then the values are 15, 17, and then 2, and then negative 15. All right, so let's take a look at the formula. So the formula right here, it tells me that the current position equals to the previous position, values of the previous position minus the values of the previous position, the one before that, right? The one before that. So basically, current position, the value of the current position equals to the value of the previous position, and then minus 2 position before, all right? 2 position before. I don't even know how I should say it. I guess I can say position 2 position before. So that means if you use this formula right here, let's verify it. Let's verify it. So for example, if you're trying to find the values of position 3, you know it's a 2, but let's verify it. So that means you will have the value of position 3. The value of position 3 should equals to the previous position, which is position 2. So the values of position 2 minus the value of position 1. So that means you're going to have 17 minus 15, which equals to 2. So that's correct. All right, it is correct. So we can basically use this formula over and over and complete our table. All right, we can use it and complete our table. So let's try to complete this table. Let's try to find some more values, because having 4 values is probably not good enough. All right, so if you want to try to find the values of position 5, you're going to need the previous one minus the one before that. So that means you're going to need negative 15 minus 2, which will get you a negative 17. So that means right here you will need a negative 17. All right, let's keep going. Let's try to find the next one. So the next one is position 6. So if you want to find position 6, you are going to need to find the values before that, which is negative 17, minus the values before that. So that means negative 15 right here. And then the 2 negatives becomes a positive. So that means you'll have negative 17 plus 15, which equals to negative 2. Negative 2. All right, let's keep going. I bet there's going to be a loop somewhere down the line. All right, so if you want to find the value of position 7, you're going to need the value of position 6, which is a negative 2, and then minus the one before that. So that means you'll have negative 17 right here, and then 2 negatives becomes a plus. Now you add positive 15. Positive 15. Oh, it seems like this is the end of the loop. All right, so let's do one more just to be safe. All right, let's do one more just to be safe. So if I want to find position 8, you are going to need one before that, so which is a 15, and then minus negative 2, which you will get 17. All right, so I can see that it repeats. All right, it repeats every let me see, every what is it 7 position. So this is one cycle, and then after that it just repeats. After that it just repeats. So it will repeat every 7 numbers. So 15, 17, 2, and blah blah blah, and then at position 7 it will repeat. So 15, 17, and then 2, and then negative 15, and then keep going. So if it repeats, now you're trying to find the sum of the first 60 terms. You're trying to find the sum of the first 60 terms. Oh, you actually don't even have to. Find the sum of the first 60 terms. As long as you find the sum of the first 6 terms right here, and then you will have to add all of them. So let me see. Right, so that means right here you're trying to add them up. Alright, so you're trying to add all of them up. Well, wait, hold up. So these numbers can cancel out. So if you're trying to add all of them, if you're trying to add this thing up, 15 and negative 15 they cancel out, 17 and negative 17 cancel out, 2 and negative 2 cancel out, so you end up getting a 0. You end up getting a 0. And then, so that means from 1 to 6 you will get a 0. From 1 to 6 you will get a 0. And then 7 to 12 you will get a 0. 13 to 18 you will get a 0. And then all the way to 54 to 60 you get a 0. So when you add all of them up, you will get 0 plus 0 plus 0 plus 0 plus 0, and then you will just get a 0. So your final answer is 0. Wow, this is all that work just to get a 0. Let me see the next one. Find the sum of the first 80 odd positive integers using sigma notation, then evaluate the sum as a product of 2 integers. Alright, so let's go ahead and write sigma notation. So use a table again. So let me write out a table for this. Alright, let me write a table. So you'll need position number and then the value. So 1, 3, 5, 7, the first 80 odd positive integers. Okay, so that means at position 1, you are looking at a 1, and then 3, 5, 7, 9, 11, 13, and so on until you hit 161. Position 1, 2, 3, 4, 5, 6, 7, and then until you get to 80. And now you have to write, let me see, you're writing the sum, okay, using sigma notation. Alright, so that means you will have to first figure out how to get from one value to the other one. So you have to get from one value to the other one. So this is obviously is a plus 2, plus 2, plus 2, plus 2. So if you want to write a notation, you are going to need something like this. All right, first of all, you will need that, and then you will need it start at 1 and then it ends at 80. And then let me see that evaluation using sigma notation. So that means you will need to have, let's just do an explicit. All right, let's do an explicit. So that means you're going to need the first value the first value, and in this case it's a 1. The first value, and then after that you are going to need to do plus the difference. The difference is 2, and then n minus 1, and then n minus 1. So let's use a calculator and find if and then find the answer for this. Alright, so using a calculator, you are going to need to put math and then summation, and then let's just say this is n equals to 1. It stops at 80, and then I need 1 plus 2, and then I need n minus 1, close parenthesis. 6,400. So when you add them up, you should get 6,400. Alright, moving on. There's not a lot of word problem on this one, so I guess let's go to the next one. Arithmetic sequence. So you say you're having trouble on word problems. Let me find some word problems. All right, here we go. A crew is tiling a hotel lobby with a trapezoidal mosaic pattern. The shorter base of the trapezoid begins with a row of 8 tiles. Each row has 2 additional tiles until the 20th row. Determine the number of tiles needed to create a mosaic each side. You know what? I think I'm gonna change some numbers. So instead of me doing your homework assignments, I can change some numbers, but I'm still gonna do the same problem. How about I will just change it to 40 rows? Right? I'll change it to 40 rows. And then and then instead of 2 additional tiles, I'll change it to 3. I'll change it to 3 additional tiles. Alright, so like I say, whenever you're trying to solve a sequence problem, write yourself a table. Alright, write a table, and then you are going to have position number, which in this case is going to be your row numbers, and then the values is going to be the number of tiles that you need. Alright, the number of tiles. Alright, so in row 1, let's see. So in row 1, you will have 8 tiles, and then each row after that, you'll have 3 more tiles than before. So that means you're going to have to do a plus 3, plus 3, plus 3, and then just keep going. All right, and then just keep going. So that means 8 plus 3 is going to be 11. 11 plus 3 is 14, and plus 3, and then plus 3, and so on. So now you're going to have to determine the number of tiles needed to create the whole thing. So you will have 40 rows in total. So you will have 40. You will have a total of 40 rows. So all the way into some number, and then you have to add all of them up. So let's write the sigma notation. So the sigma notation is going to be, you start at row 1. All right, you start at row 1, and then you will stop at 40, row 40. And then let's do the explicit formula. So you will need the first value, and then plus the difference, and then right here you have a n minus 1. So we already know the first value is going to be 8, and then the difference between each one is 3. It's 3. So that's going to be your segment notation, and then now go ahead and solve it with a calculator. Well, if your teacher, is good with you just writing the notation, that's fine. But let's try to solve it. I mean, we're here anyway. Let's try to solve this. So that means I will need, let me see, math, and then right here, and then you will need to have the starting number, which is a 1, and then it stops at 40. And then you are going to need to put the explicit formula, 8 plus 3, and then times n minus 1, close parenthesis, and hit enter. Alright, so if you add them all up, then you are going to have the answer. The answer is 2660. Alright, that's your answer. That is if I change the numbers. Alright, so make sure you understand that I changed the numbers right here and right here. Yeah, like I say, I don't want to do your homework for you. Alright, I want you to do your own assignments. So I changed some numbers. You should be able to figure out how to do the original numbers. Alright, how to solve this problem with the original numbers. Alright, what else? A snowmobile competitor travels 12 feet in the first second of a race. If the competitor travels 1.5 additional feet each subsequent second, how many feet did the competitor travel in 64 seconds? Okay, let's change some numbers, just like I did before. Let me change some numbers. So let's just say you travels 20 feet, all right? 20 feet in the first second of a race, and then travels. How about how about 3 additional feet? All right, 3 additional feet each subsequent seconds. And then how many feet did the competitors travel in 64 seconds? Let me just change it to 70. All right, 70 seconds. So I changed some numbers, and let's see if I can solve this. So let's write a table. So this table, you're going to need the position number, and in this case, it's going to be your time. So the time is from 1, 2, 3, 4, and then keeps going until you hit 70. And then down here, the values is going to be the distance. All right, so the first second you're already at 20. So that means you have a 20 right here. And then each subsequent seconds, you'll have 3 additional feet. So that means 23 right here. And then you'll have a 26, and then 29, and then it will keep going until you get to 70. So each second you are advancing 3 feet. All right, 3 feet. All right, now let's go ahead and write a segment notation. So you can use that to calculate what is the final distance. So the notation is going to go like this. So you will start at 1 second, and then you end it in 70 seconds. And then just like before, you are going to need when position number is 1, the values, you're going to need the values right here. and then plus the difference between each value, and then you need a n minus 1. So in this case, the first value is 20, and then the difference between each value is a positive 3. So this is going to be your sigma notation. All right, now solve it with a calculator. Solve it with a calculator. So calculator here. All right, so let's get the sigma notation. So that means you need math, and then summation, and then, all right, let me put the n right here, and then the starting number is 1, and then you will end it at 70, and then the explicit formula is 20 plus 3 times n minus 1, and then close parenthesis, and then hit enter. All right, so after 70 seconds, it's going to the guy is going to travel a total of 8645 feet. All right, 8645 feet. All right, so like I say, I changed some numbers. So when you solve this problem yourself, you better change it back to the original numbers. Number 9 looks pretty similar to the one before. I'll skip that. Number 10. What is your total salary? Oh, how about number 11? Number 11 looks interesting because it is asking you for the first value, whatever that is. All right, it's not asking you for the total. The total is already given to you, and then it's asking you for the first value. Okay, this one is interesting. Let's do this one right here. Let me see. On the first birthday, grandma gave her a check, each at the same amount. At 7 years old, Anna's grandma has given her a total of $610. At 18 years old, Anna's grandma has given her a total of $1,270. That amount of money is nothing. You can't even pay for a textbook in college. Huh. How much money did Anna's grandma give her on her first birthday? All right, so let's write a table. So I will put the year up here, and then the total amount of money down here. And then obviously you start at 1 and 2 and then so on. And then at 7 years old, you are at 610. 610. And then at 18 years old, you are at 1270. And then now they're trying to ask you how much money that she's got on the first birthday. You're trying to find when position number is 1, what is the value? All right, so this is what they want. All right, so if you use the explicit formula, let me see. So you're going to need, let me see. You're trying to find this number. You're trying to find the value when position is 1. And then the total is 1270. And you're trying to find this, so keep it as a variable. And then the difference between each year. The difference between each year is going to be, let me see. Okay, so from 7 to 18, you are looking at 11 years. 11 years. And then within this 11 years, he's got 1270 minus 610 equals to $660. $660 total, and then in 11 years. So divided by 11. So that means each year. That means each year he's getting $60. Each year he's getting $60. So I'm going to put it right here: 660 divided by 11. So each year he is getting $60. All right, so 60, and then to the next one is 60, and then to the next one, to the next one, to the next one, until you get to 1270. So that means the difference is 60, and then the final year is what is this? It's 18. So 18 minus 1. All right, now solve this thing backwards. Equals to, let me see, 60, and then right here you got a 17. 60 times 17. So 1020, and then that means first year you have one, which is 250. All right, 250. So that means on the first year he got 250, and then every year after that, he's getting an extra 60 every year, extra 60 every year until it gets to year 18. He's going to get a total of 1270. Oh, I forgot to change the numbers. Oh well. All right. So that's it for the word problems, I guess. All right, moving on. Let's take a look at the next one. Geometric sequence. All right, geometric sequence. Geometric sequence. Where are the problems at? Okay. Right. So these you can use a calculator. Just use calculator on this. All right. There's no need to do it by hand. All right. Here we go. Finally, word problems. Melina receives a chain email that she forwards to 7 of her friends. Each of her friends forwards it to 7 of their friends. Write an explicit formula for the pattern. How many will receive the email after 6 forward? Okay. Oh, geometric. You're going to use a different formula for this, I believe. You will need to have the first. Let me see. Okay. All right. So let me All right. Let me change some numbers. All right. Let me change some numbers. So let's just say this is 8, and then forwards to 8 of her friends. All right. Write a table. Let's make a table. We always want to make a table. So how about number of forward And then right here will be the total number of recipients. All right, so number of recipients. Hopefully I spelled that right. All right, so 1, 2, 3, 4, 5, and so on. All right, so you start at 8. You start at 8, and then each of our friends forwards it to 8 other friends. So that means you times 8. That will get you 64. Okay, so that means right here you have a times 8, and then times 8, and then times 8, and so on. So you're always trying to times 8. And then after 6 forwards, how many of them will receive email? Okay, so that means you're going to have to use this formula right here. For geometric, this is the formula. The first value times the ratio to the power of n minus 1. Alright, so if you want to find the values after 6 forward, you're going to need the first value, which is 8, times the ratio, which is 8 again, and then after 6 forward, so 6 minus 1. So that means 8 times 8 to the 5th power. So that means 8 to the 5th power. Alright, use a calculator on this. 8 to the 5th power, or actually, okay, and then times 8 again, so 8 to the 6th power. You will, so this many people is going to receive it, alright, so 2, 6, 2, 1, 44. That's a lot of people receiving an email. Alright, so that is how you work this problem. Make sure you change it back to the original number when you work this out. All right, I don't copy my answers. That looks pretty similar. That one looks pretty similar. What about this one right here? A bungee jumper falls 35 meters before his cord causes him to sprint back up. He rebounds off the he rebounds of the distance after each fall. I think this one is missing a number right here. He rebounds, like probably a percentage. There is probably missing a percentage right here. He rebounds maybe 10% of the distance after each fall or something like that. Yeah, it's probably missing a number. Well, then that means you don't have the ratio. If you don't have the ratio, you can't solve it. Find the first 5 terms of infinite sequence representing the vertical distance traveled by the bungee jumper. Include each drop and rebound distance as separate terms. Yeah, I think it's missing information right here. Yeah, you gotta give me the ratio, but there's no ratio. I don't think you can. I don't think you can solve it. All right, let me solve another one. Let me see. A newly developed and researched medicine has a half-life of about 1.5 hours after it is administered. The medicine is given to patients in doses of D milligrams every 6 hours. What fraction of the first dose will be left in the patient's system when the second dose is taken? Alright, so the half-life is 1.5 hours. Half-life is 1.5 hours. So every 1.5 hours, you only have half of the original. And then the medicine is given to patients in doses of D milligrams every 6 hours. Okay, so that means it's going to look something like this. Hours, and then um, the amount, I guess. The amount. That's so. Let me see. Okay, so when you first give the medicine as cereal, you are going to have a D amount of medicine. But then after 1.5 hours, you'll have half of that left. You'll have half of that left. And then another 1.5 hours, you will have half of this. So that means 1/4 of the original. And then another 1.5 hours, you will have 1/8 of the original. And then after 6 hours, you are going to have such a little amount, 1/16 of the original. So the ratio is times 1/2, times 1/2, times 1/2, times 1/2. What fraction? What fraction of the first dose will be left in the patient's system when the second dose is taken? Alright, so the second dose is going to take after 6 hours. After 6 hours. So that means you are at right here. You will have 1/16 of the original. Alright, you'll have 1/16 of the original left when you take the second dose. When you take a second dose, you will still have 1/16 of the original left in the system. Find the first 4 terms of the sequence that represent the amount of medicine in the patient systems after the first 4 doses. Alright, so you're gonna need a new table for this. Alright, you'll need a new table. So instead of hours and amount, I'm gonna do doses. Doses and then the amount. Alright, so on your first dose, you have D amount. You have D, whatever that number is. And then on your second dose, which is after 6 hours, you're gonna do the second dose. You will have the leftover from the first dose, which is 1/16 times D, plus whatever the new dose that gets you. The new dose is, whatever that gets you. So you'll have 1/16 times D plus D. Okay, so that means you can pretty much add them up, and then you will get, let me see, you will get 17/16. 17/16 of the original. So you have a little bit more because you just took an extra dose. Alright? You just took an extra dose. Okay, and then that means the ratio is going to be times 17/16. Times 17/16. And it's most likely going to be the same. So that means 3, 4. So you have to do it again. Times 17/16, and then times 17/16. And then, so you're actually getting more. The number is going to get bigger and bigger. Find the first four terms of the sequence that represent the amount of medicine after the first four doses. All right, so all you have to do is just keep multiplying 17 over 16. It's going to be a nasty fraction. Use a calculator on this to get this number right here, and then get that number right there. All right, find a recursive formula that can be used to determine the amount of medicine in the patient system after nth dose. Okay, so let me see. A recursive is you're going to need this formula right here. So recursive, you always need the previous value. All right, you need the previous value. So the recursive formula is going to be the previous value times the ratio, which is 17 over 16. So this is the recursive formula, I think. 17, yeah, there you go, that's the ratio. Wow, these are pretty tough problems. I'm surprised that you guys have to, do all these. Oh, man. Right, so yeah, I did quite a bit of word problems. Hopefully that helps you out a little bit. Yeah, so if you have any more questions, just let me know. I'll do my very best to help you. All right, I'll just try my best.